An AI agent can scan millions of network endpoints, spot behavioral patterns, and identify a system's weakest point in the time it takes a human to open a terminal window. The speed of cyber warfare has accelerated exponentially. Historically, penetration testing required hours of manual command line typing to probe a single target. Today, AI agents can execute reconnaissance, payload generation, and exploitation scripts concurrently across hundreds of targets without ever taking a break. To understand how these agents operate, we are going to build a simulated automated attack chain step by step. We will execute this entirely within a secure, authorized lab environment. Constructing this offensive workflow from the ground up gives us a clear look at how automated attacks function. Mapping the exact steps of an AI-driven breach is the only reliable way to engineer modern, resilient defenses. Step 1 is selecting the right engine for the task. Commercial language models like ChatGPT or Claude offer powerful real-time capabilities and strict safety guardrails. Open source or coding-specific models like Llama or DeepSeek give you the flexibility to run complex automation locally. These legitimate research models stand in sharp contrast to underground systems like WormGPT. Those platforms are specifically trained on malware data and operate entirely without ethical guardrails, allowing malicious actors to generate full attack chains automatically. This 3-column grid outlines the capabilities, privacy, and use cases of these different tiers. Commercial models prioritize speed and safety. Open source models offer complete privacy and customization for developers. Underground models remove safety constraints to optimize for malicious exploitation. The AI engine you select at this stage dictates your technical bandwidth. It also establishes the legal and ethical boundaries of your entire cybersecurity workflow. We initiate our lab attack chain by building a reconnaissance bot. Looking at this prompt, we can instruct a commercial LLM to generate the initial code. Write a safe Python script to automate DNS enumeration and pass the output to recon.ng for mapping. The AI outputs a ready-to-use Python script. When we run this code, it automatically pulls domain data and feeds it directly into security platforms like recon.ng or Spiderfoot to begin mapping the target's entire digital footprint. During execution, the agent takes over. It autonomously scans the assigned targets, cross-references databases, and extracts exposed API keys or hidden subdomains without requiring manual input. Intelligence gathering has completely transitioned from a slow manual search process into a persistent, automated data scraping operation that scales instantly. With our target mapped, we move to vulnerability scanning using a web application testing platform like Burp Suite. To enable automation, we install AI-assisted extensions such as BurpGPT or FlowGPT directly into the testing environment. Next, we configure these extensions to communicate with each other. We link the reconnaissance plugins that gathered our target data directly to the plugins responsible for generating payloads. By chaining these specific tools together, the system can autonomously execute high-speed fuzzing, bombarding the application with massive amounts of targeted, AI-generated data inputs to test how the system reacts. This flowchart illustrates how the chained system bypasses standard security. The AI mutates the data packet in real time, routing the payload around the web application firewall. During this bypass, the system analyzes response behavior, identifying hidden logic flaws, structural vulnerabilities a static scan would easily miss. Chaining AI plugins effectively transforms a single penetration tester into an automated, highly efficient testing team capable of adapting to defenses on the fly. This adaptability extends to social engineering. By combining text generation AI with voice cloning tools like 11 Labs or Deepfake Lab, attackers construct multi-layered, hyper-realistic phishing campaigns in minutes. This side-by-side text analysis compares the two approaches. The left side shows generic, easily identifiable markers of a human-written mass phishing attempt. The right side shows an AI-generated attack, populated with specific references scraped from the target's digital footprint. Once a target interacts with that deceptive layer, the payload delivery begins. Automated frameworks generate polymorphic malware, code specifically designed to evade static antivirus software. This animated diagram shows how polymorphic malware works. By continually altering its code structure, the payload bypasses checkpoints looking for known threat signatures. To counter this, AI behavioral detection systems evaluate behavior over time, trapping the payload based on its anomalous movement pattern. Relying on static defense against adaptive code is a losing strategy. Modern protection must be behavioral, dynamic, and equally intelligent. This graphic outlines the first priority in building a defensive architecture: minimize your digital footprint. Executing data removal and regular auditing actions starves automated reconnaissance bots of the open-source intelligence they need to profile you. Next, establish protocols for verifying identity. Look for visual artifacts in video, like unnatural blinking or edge blurring around the face, and listen for audio clipping or flat emotional cadence to identify AI-cloned voices. At the organizational level, secure architectures require a zero-trust model. This means verifying every single access request, regardless of its origin, paired with immediate, automated vulnerability patching across all systems. Comprehensive protection relies on this dual strategy. You aggressively minimize your attack surface on the front end, while deploying active, AI-driven behavioral analysis across your internal network. We've walked through how AI accelerates the initial reconnaissance, automates the discovery of web vulnerabilities, delivers mutating payloads, and requires a behavioral defensive framework to stop it. If you are building your skills in this environment, start with the fundamentals. Focus on basic coding and running local, open-source models first. Master the underlying mechanics before you attempt complex agent chaining. The integration of artificial intelligence into cybersecurity represents a permanent baseline for all future digital conflicts. The speed of execution has increased, and the offensive tools are constantly adapting to defenses. The choice now is to understand these tools and apply them responsibly. Adopt these ethical practices in authorized environments. Subscribe for more technical cybersecurity breakdowns, and engage with the community below to build your skills. I will see you in the next one.